In this work, we investigate unimanual scaling interactions that employ gaze-hand-object alignment as a mode-switching cue, thereby enabling unimanual object manipulation. We designed 4 unimanual scaling techniques by combining gesture type, gaze-hand alignment strategies, and control parameters as design vectors. The first technique is pinch to zoom, in other words, PTZ area-based scaling. Stereoscopic view area refers to a rectangular area defined by the thumb and index fingertips, projected from left and right eyes. When the area overlaps with the target, the scaling starts. The scaling factor is calculated by the change in the area. Scaling stops when the overlapping area falls below a predefined threshold. The second technique is pinch to zoom angle-based scaling. The mode switch to initiate scaling is triggered when the hand enters a specified angular range from the gaze ray. The scaling factor is determined by the angle between 2 vectors, one from the gaze origin to the thumb tip, and the other from the same origin to the index tip. The scaling ends when the hand moves away from the gaze. The third technique is pinch to zoom span-based scaling. As with the angle-based scaling shown earlier, scaling starts when the hand moves near the gaze ray. On the other hand, the scaling depends only on the distance between thumb and index fingertips. Last technique is push-pull depth-based scaling. Scaling begins with a pinch gesture when the hand is aligned with the gaze and ends when the pinch is released. The method follows the metaphor of scaling down by pushing the object away and scaling up by pulling it closer. The user study was conducted to evaluate the robustness of the mode switching mechanism, focusing on minimizing unintentional mode switches and the technique's capability to provide accurate scaling. The task was to first translate the object and then scale it. As a result, the overlap-based alignment of PTZ area showed the most robust mode and performance, while the angular dispersion and pinch-assisted alignment led to more frequent mode switch errors. On the other hand, the PTZ area resulted in a low scaling performance. In particular, the scaling performance were significantly affected by the target scales. The push-pull depth scaling enabled the most accurate scaling, leading it to be the most preferred unimanual technique. However, as frequent hand tracking loss near the HMD increased the scaling error rates. From the result, we derived the following design guidelines for practical applications. In this study, we compared unimanual scaling gestures in 3D and its mode switching technique that exploits the alignment between gaze, hand, and the object to support full-stack unimanual object manipulation. We expect that our findings will contribute to the development of natural and intuitive unimanual interaction techniques supporting greater convenience and accessibility in XR environments.